Hey class, welcome back from spring break. I hope you've enjoyed your time off and that you're ready to get back to work. So we're in the coding phase, which I think is great. Um, so we're going to create or run 3 projects today. I'm not sure if we'll get through all 3 of them. Um, but the first 2 are the types of questions that you can expect to get whenever you're interviewing. Um, so there's usually a technical screening if you go through a recruiter and they try and filter out the people that are either poorly matched or have absolutely no idea what they're doing. And then if you get past that, then they match you up with someone from the team, either the hiring manager or one of the senior members, and they'll interview you and see whether or not uh, they they think enough of you to bring you in. But if you get matched, if you go through the recruiter and you get matched there and you do well enough on your phone screening, then you can expect to go in. And then it's in the in-person interview that they'll, or now with everything remote, it's during that technical interview when you'll usually get a question, usually just a single question, and then the interviewer will, if you're struggling, they'll try and help you work through the problem, or if you have any questions, you can ask them. But really, it's your chance to show that you have some idea what you're doing. You've written programs before. You've spent more than 2 or 3 hours learning how to write code. so um, so it's really a chance to do well. So these are just a couple of the problems, and then the third problem that we'll look at will be the spanning trees, which I said, which before the break I said that we would work on whenever we came back. So 3 problems. We'll use 3 languages, and more than mastery of any single one of them right now. I want you to move past the intimidation factor. It can be prohibitive to think that you just don't know where to start. And so, as much as possible, I will hope to remove that barrier to entry for any individual language or genre of problem. And while you may, you are guaranteed to not know everything whenever you leave my class. Hopefully, you have enough confidence to at least explore and see that becoming a good developer doesn't necessarily mean walking around with the knowledge for everything that you'll ever need in your head. A lot of it is developing the confidence that you'll be able to find what you need or create it as you go along. And so let's take a step in that direction. So the first problem that we're going to look at is going to be FizzBuzz. It's a really simple problem. And we're going to write it in JavaScript. And so the JavaScript engine that we use, it comes from, it is borrowed from the V8 engine that Chrome uses for their JavaScript tool. So whenever we write something and we execute it here, we're writing it against the V8 engine, but that project has been separated, and you can run JavaScript programs as a desktop programming language now, or as a server-side programming language. So the barrier to entry here is that you have to install it. So you can install it on Mac, on Linux. You can get it from source and compile it on any system. X whatever it's written in. It's probably C++, I would imagine. But Mac and Windows and Ubuntu all have these pre-compiled packages that you can just install. So pick the appropriate one. LTS versus current. So LTS stands for long-term service. If you're not sure what to get, get this, but really you can't mess it up. Just pick one and go from there. But remember which one you've installed, because whenever you check documentation, it's the version is going to matter, right? So you see that the documentation varies based on which version you have installed. So let's see. So a quick note on this. So throughout the first two examples, I'm going to use Visual Studio Code, and that you can just search for VS Code, download, and then you can install the appropriate package for that. Okay. Alright, so it's nifty in that you have your control of Explorer over here. You can create your directories and files and manage your directory structure from here, which I suppose isn't all that unique, but it is a convenience, and if your IDE doesn't have it, then it's a bit of a hindrance. Okay, so FizzBuzz. We'll just call it index.js out of habit. So it's convenient to have a command line shell here, so you can make the terminal and the side navigation disappear using shortcuts, Control B to make this go away, and Control backtick or Control tilde to make this go away, or appear. Okay, so first thing I do, after 16 years after I finished my undergrad, whenever I write a new program, the first thing I always do is write hello world and make sure that it executes. Alright, looks good. So if you can't get hello world to work, I mean, I know it seems trivial and like you should move beyond it at some point. You should definitely extend your abilities beyond hello world. But it's beautiful in its simplicity. If you can't get to that point, then something is broken that you need to deal with before you go any further. And so it's a reasonable place to start. But then it's also a way for you to ensure something's going on there. Okay, but it's a way for you to ensure that you can perform basic commands. Right, and so in that case, it was in a directory that wasn't appropriate. Alright, so I had to switch from this top level directory into FizzBuzz. Okay, so the problem for FizzBuzz, what you'll be asked if you're given this problem, is for multiples of 3, print fizz, and for multiples of 5, print buzz. And then if it's a multiple of 3 and 5, print FizzBuzz. So you can brute force this, though, if they give you a range like between 1 and 100, or they may tell you to write a function that allows them to pick some positive number. But in the end, it's going to be a series of if-else statements, and it's just making sure that you understand how to arrange them such that you handle all 4 cases. The case where it's none of them, the case where it's both of them, and then the case where it's one or the other. So let's write it as a function, and then we'll have it accept some upper limit, and we'll run through all of the all of the cases. So I use the newer syntax to create functions, but if you're more familiar with writing something like this, right, or upper limit, which is really what that variable is, then you can do that. But I like the simplicity of the new syntax, the ES6 syntax. Okay, so then we have our for loop, and we're not going to return anything, but we need an iterator, and we'll start it at 1 because it's the positive numbers as we were given. If it's less than or equal to our upper limit, we'll execute it. And then now we need to handle all of our cases. And so I know I didn't specify the requirements very well, but that may happen. It may be that they give you the requirements verbally and it's not exactly clear what you need to do in order to solve it. And that's an excellent chance to show off your communication skills during the interview. Ask questions, ask follow-up questions. At some point, you have to get started, or you have to admit that you have no idea what's going on. But hopefully, you just need a little bit of information, and they'll help you get started, or some small point was missed. But in this case, in order to print FizzBuzz, it becomes apparent that you just need to loop over all of the numbers in your domain and then execute those tests. Right? So then what order is the test? Well, if we're going to use if-else statements, then we know that only one of them can execute. And so the pattern, the solution, is to start with the most specific and then work your way backwards from there. So the most specific is the case where it's both a multiple of 3 and a multiple of 5. So then we test for divisibility using our modulus operator, or the remainder. And if it's a multiple of 3 and a multiple of 5, then it's a multiple of 15. So then we test when dividing by 15 if the remainder is 0, which means it's a multiple of 3 and 5. Then we print FizzBuzz. Otherwise, if it's a multiple of 3, print fizz. And if it's a multiple of 5, print buzz. And you'll notice that we did need this extra if condition because there's this there's all of the values that are all of the even numbers, for example, which are not divisible by 3 or 5, except whenever they're divisible by 30. Right? So most of the even numbers are going to fall in that case, and if we had it print buzz on the else, then it would have been incorrect. So as a rule, whenever you're working through these word problems, trying to understand how to translate it into code, if there's a condition given, put it in there, and then if you can logically prove that that condition is not necessary, that it falls into some default case, then you can remove it later. But as you're translating from requirements into code, if a condition is given, you should specify it, usually in the form of an if, because that's how it's written on the page. If this condition exists, then do this action. Okay, so that should work. Now, let's invoke it. So we'll do this for everything up to 100. It looks like it worked, but we don't really know. So let's also include the number itself, so we can verify. Okay, so usually you can tell right at the beginning whether or not it's doing what you want. So multiple of 3, prints 3, multiple of 5, prints buzz, 3, fizz, fizz, 5, buzz, fizz, and then at 15 we got fizz buzz, which is what we wanted. At 30, 45, 60, 75, and 90. Perfect, so it looks like it's working as desired. So for some of you, and especially when you're first starting out, this is as complicated a technical challenge as they'll give you in the interview. And they just want to make sure that you can work through coming to an understanding with requirements, talking through any confusion with your team members, and communication is a major attribute that can be credited to you during an interview. So do your best to show your communication abilities when you can. And so asking questions, it's not about coming off as though you know everything as much as it is showing that you're a person that they wouldn't mind working with, both for technical reasons and because you're not a know-it-all, right? So just keep that in the back of your mind. Okay, so that was the first one. This project can be written here as well, right? So we claim that it's the same tool underneath. So you can do FizzBuzz here directly in the console if you haven't installed VS Code. Equals 0, and so forth. You could actually copy this. Whoop. Right, so that defines the function, and then we invoke it. And it executes just as well. So if you don't want to, you don't have to install it. But if you want to work on the same file over time, which you'll want to do for anything other than trivial coding examples or very simple programs, then you'll want to install this so that you can run it from the command line. You can make a small adjustment and then run everything again. And I encourage you to do that sooner rather than later, rather than waiting until you need it, because as a developer and in life in general, the habits that you develop will end up becoming how you represent yourself. So much of doing well is establishing good habits, and a habit that you should get into now while you're still learning how to develop and you haven't really established many of these patterns is this quick cycle. So make a small adjustment. It's the same thing that we were learning with induction. So you start with something simple. You start with some base case like hello world, and then you make a small adjustment, and by compiling and executing and testing your code often, you're essentially doing that k+1 step. You're always doing that inductive step. It's only one step further from something that you had already established was working. And so if it's broken, it's a very simple fix. And if it works out, then you've banked your progress. But it's very tempting, especially early on, to make a series of changes into something that adds up to a very dramatic shift in code, and then something is broken. You're not exactly sure how to read the compiler errors, or they're just not helpful, and it becomes near impossible to trace it back to whatever it is that's actually broken. I would encourage you to develop this habit of working on your desktop and then figuring out, based on whatever language you're using and platform, figuring out how to make small changes and execute them in this rapid cycle fashion. And I think as soon as you get there, you'll find that it's a lot easier to make progress and a lot less intimidating, because you don't dread the next time you compile it. It's just a matter of course. Okay, so that was our first one, JavaScript, low barrier to entry. You got it. So now the next one is going to be, we're going to write in C#. And so just type in .NET download, and then you're going to install the SDK. So the runtime will execute these programs. The SDK is for the software development kit, and as software developers, you want the SDK. That actually allows you to compile stuff. So it comes with the compiler. Okay, and then so you just download it and install it, and then you can use VS Code to develop as well. So Visual Studio Professional is going to be kind of the standard for .NET, but for open source developers, you can use VS Code, and the programs that you write beginning with .NET 5 will execute. You can compile and execute them on Linux and on Mac as well. And so C# has become this cross-platform language, and which I think is fantastic, because it's the one I've been using primarily since 2005, although recently I've become quite fond of JavaScript as well. Okay, so now, no, not there. Whatever. So if you can't figure out how to use this, you can always go to the command line. So we are going to make a banking transaction app. So it'll be fairly straightforward. It'll let us run through some of the steps. I'll have you create the libraries as well, or I'll have you create it as a library, and we'll go through how to set up some unit tests and so forth, and then we'll move on to Prim's algorithm and spanning trees and such. Okay, so we need to create our app. We'll call it banking. And then we're going to have this in 3 levels. So we're going to have the application. We're going to have the service library. And then we're going to have the tests. But really, service library, it's kind of two things joined in one. Well, yeah, it's fine. We'll survive it. Okay, so well, let's break it up because the test is going to be 2 levels deep. So I feel like the libraries need to mirror it in structure, and hopefully that'll make sense here in a minute. So we'll show it here as we go along. Okay, so now we're going to redo this and we're going to make it as a libraries directory. Okay, and then we can shorthand over here and create the folders and so forth. So let's call this one service lib. And this one will be service lib tests. And the unit tests, to some extent, are your proof, your submitted proof that the code worked when you finished touching it. So it's kind of an exhaustive list of all the things you claim that it does, and you can prove it through your unit test. And then it's an establishment of boundary conditions as well. So you show that it works whenever it's given appropriate input, or the expected input, and that it fails in predictable ways, in documented ways, whenever it's given input that isn't in its prescribed range. And so the tests are a really good way to establish this. Okay, so we'll touch on how to create an application because that's really what's familiar. But I'm more concerned on this example with establishing unit tests. But let's do that example first. So to get a new console application, you just type .NET new console. I think you can also do .NET new web app, and it'll give you an API, a backend API that you can use. So whenever it creates it, it'll create a project file, which gives kind of a summary of what the project is. And then it'll give you an entry point, and that's program.cs. So we have this. Let's see if we can run it. Okay, so we got hello world, but that's what we were given. If we make a small change, does it still execute? It does. Okay, so now we want to move into the others, and we want to create a dynamic linked library, a DLL, or a service project, a library project, whatever you want to call it. But whenever you're managing large, complex projects, you reach a point where you have more than like 15 files or something like that, and it just stops making sense to have everything live in one place. And so especially for larger teams or more complicated projects, you want to reuse code, not just within a project, by creating this class, but amongst many projects. And so you start mirroring what you see with the frameworks, and that you create these packages that can just be consumed by your other projects, and the packages solve some business cases or such as communicating with a database or anything. And so you have one package that communicates with your database, and it provides you with the services that will handle all of the database transactions and managing the connections and responding to certain inquiries, like whether or not a user has been locked out and so forth. And so it provides these convenience methods. But it's all done in one place so that any project that you have that requires this a solution to this common demand is shareable. It's readily shareable using this library. And so code that's meant to be used among many projects gets moved out of the application, so out of this program.cs, or out of the project that houses it, and into a library, and then that library gets used by the other projects. And so it becomes a dependency for this individual application, and it lives on a bit of a higher level. So we're gonna show you how it's possible to call code written in a separate project from right here. Okay, so we're in application and we want to get to libraries. Okay. Okay, so now we want .NET new, is it library? No, okay. So we're gonna have to look it up. It's not a big deal. .NET new library. Okay, so these are all the things you can pass to new. I think we want class lib. And then the unit test one will be MS test. Okay. So we run it, it creates the project for us. Now it's available down here. It creates this default class, and for this one there is no entry point. So it has to be consumed from something that does have an entry point, which both our unit tests will provide and the application as well. But just to make sure that everything is set up appropriately, let's create a static method. Announce yourself. So we create this method. We'll be able to invoke it without instantiating the class. And then all it does is prints a line saying its class name and method name. And I use this so that if I do a find and replace with this using some tool, that it'll detect that this is not just a word in a string, but it actually references this. And then this is the format for an interpolated string, as we did with the backticks in JavaScript. So it's the way that you inject variable data into a string. Okay, so now okay, application should still run. So now I think I don't remember the syntax, so we'll just look it up. Okay, so we're adding a single project reference. This is our application, and this is the library we want to reference. So we can copy it if we want, but we can also just remember. So application.csproj reference. And then you reference the project file. And then it'll build it each time it compiles because it's a dependency. So now we don't have to compile this separately because we reference it here, or we will. Using service lib. Oh. Wrong file. So we want to reference it in the application, right? We want to reference it up here, even though it's defined over here in this other project. That's kind of the whole point. Okay, so we have our hello world. Let's make our reference. Alright, so we should be able to just run it, and it'll compile. Okay, so it printed out this as expected, and then it printed out completed, so everything executed just fine. So we're going to do something similar with the unit tests. So because we know we're going to need both of these projects, we can create them now, or we could do the work and then create the unit tests later. But because I'm trying to establish good habits, I want you to create the unit test project at the same time you create the project that needs the tests. And if you end up not needing the library, the amount of work that you throw away from having the unit tests isn't all that much. But more importantly, you will have reinforced the habit of creating projects for your unit tests. Okay, so let's deal with that. Okay, so you can see it's creating it over here. And then we need to add a reference to the project that we're testing. So it's the exact same. Did I get that right? Sorry, I just wanted to double check that the file was actually where we're specifying. should be able to execute the tests even though there's not anything in there. Am I missing something? No. Maybe I just need to compile it. So let's try that. Well, we'll come. Oh, yeah, we'll come back to this. Not sure exactly why it's giving us that trouble, but it should be fine. So let's begin to approach our problem. So I'd mentioned that we were going to do banking transactions. So the transactions will boil down to two levels. So you'll have a bank and an account, and a bank consists of multiple accounts. And then we're only going to deal with a single bank, and we're only going to deal with internal transactions. We'll simplify it as much as we can. You're not guaranteed that these simplifications will apply to your scenario, which is why you have to talk to your interviewer to find out exactly how much they want from you. But for now, we'll just create these ourselves. So I think it's always good to put your data models in a single directory. So these are the types that we're defining. Types are essentially data models. So there would be a correspondence between this code and what you see in the database. So we have bank.cs and account.cs. And so we'll do bank first. So just like Java, you have to declare which packages you're going to use. And so system is the most common one in C#. So you'll essentially always need system. With very few exceptions, such as if you're only using primitive types in a POCO object, a plain old CLR object where all it does is store like integers and doubles and so forth. Okay, so the namespace is the name of the package that you're building on, and so it's going to start with the project. So servicelib is our project name, and then a period because there's a new directory, there's a subdirectory, and then data models. So let's type it out. Okay, so in here, once we've established which package we're amending, we declare our class. We want it publicly available. Again, the modifier types are private, internal, protected, and public. So public means anything that can see the library can see the class, and that's what we want right now. This is the bank class. Okay. So we need a way to manage the accounts. We're going to hold them in a dictionary. And in C#, if you're going to use a dictionary, you want to use a generic dictionary. So if you're not familiar with the concept of boxing, then or the cost of having to cast as well, whenever you can deal with a specific type, there is some overhead. So to spare yourself that trouble and that penalty, we use generics in C#. So here we'll declare it with a generic dictionary. And it's read-only because even though the contents of the dictionary change, the dictionary itself does not. And so these are the type parameters for your generic attribute, and it says that the key value pair will have an 8-byte integer as its key, and it'll have the object type of account for its value. So we haven't created a count yet, so we should probably at least get a dummy thing up there so that we can continue to compile our code. So let's declare that we have a concept of an account. And so again, this is the package name, and then the directory path essentially. Again, it's a public class, and we're not asking anything of it just yet. We just want it declared so that we can compile. Okay, great. We haven't broken anything just yet. Alright. So now we need to provide, so we've declared this variable, the accounts, as private, so only the bank should be able to modify the accounts. So we need to provide some way to add items to the account. So we'll expose a public method. Oh, we haven't specified our properties yet, so that won't work. Okay, so now as we add the accounts, we know that we have something that it's keyed off of. Well, whenever we were discussing relations and we talked about relational databases, we said that anytime you have a table, in this case an account table, that you're going to want a column that is table name ID to indicate your primary key for that table. So this serial number that you can use to look up your account or any other information. But you're always going to want to provide that serial number so that you have optimal read access to that item. So we know that because account is one of our classes, it's one of our data models, that it's going to have an ID. We should go ahead and add that property to account now. But it's not going to change. It's the serial number. So we need some way to ensure that it doesn't change over the life of the account. So we'll declare it as a private variable. We'll have the constructor private read only so that it won't be modified. We'll have the constructor assign that value. And then we'll use a getter and so there's a few ways to define this. You can go in here and you can say I want this code to execute but I don't want people to be able to set it through this public method, and then whenever it gets compiled, it'll have a function, so this will be used just like a property or some public variable in the class, but whenever it compiles, it turns into a function, and so there's a _get function and an _set function available to you. But this is so common, this mask that allows you to read something but not to write to it, and it gets compiled anyway, that they provided this shorthand where whenever this is used to read a variable, you can just map it to whatever variable you want returned. And so this is the modern way of providing that read-only variable of exposing that. Okay, so we have account ID, so now this works. But we just said that because we're dealing with data models, that we should really provide a bank ID as well. So if we're going to do that, it's somewhat trivial because we're only going to have the one bank. But again, habits, right? So we know that it's going to be a long because we're in the 21st century, and any serial number should be 64 bits at least. Okay, so we're only going to have the one, so we can just hard code it during the initializer phase, and then we'll expose it. Okay. So we can add an account, and then we can look one up based on the account ID. And we don't want it to throw an error. Sorry, we want it to return the account if it's found. We want it to return null if it's not found rather than throwing an exception. So before we attempt to find it in the dictionary, we're going to check to see if it's there by key. So if it's not found, return null. Otherwise, return the value associated to that key. Oh, not quite. Okay, does it still run? We've made some changes. Did we break it? No? Okay, excellent. So now we want to establish a way to transfer funds. And so, because we don't have everything we need right now to transfer the funds, we don't have account balances or anything. Those are going to live inside the account class. We have this placeholder that will remind us anytime it executes. It won't accidentally work and make us think that we finished when we haven't. It'll remind us very abruptly with this exception, this non-implemented exception, that we haven't actually implemented this method. But what's important is that we've declared the method and we can start consuming it in other places, and we haven't broken our compilation cycle, so we can still compile and test our code even with this half-formed idea of transfer funds. Okay, so now on the account, we need to provide a balance. We're not going to have multiple account types or checking types or anything like that. There's just the one generic bank account for now, but you can imagine how that might be modified later on. So it'll be an account ID and a balance, and then we'll allow our users or consumers of our class to debit from that. So whenever we initialize, we can expect to have a balance of funds. And then also, whenever we initialize it, the account belongs to a bank. So we should establish that as well. So the bank, you'll never transfer an account from a bank. You would create a new account and close out the old one. But this instance would never change bank. So that will always be read-only. And then we will have the read-only field, the mutable field of balance. Okay, so we have these private variables. We won't expose the bank property. We'll just for now, we will decide that the consumer will have to get the bank reference by some other means. It's really just there as a convenience for the account to refer to the entity which claims ownership over it. Okay, so but we do need a way to read our balance. So let's expose that. So whenever we make a deposit, we make sure that the deposit amount is non-negative. Otherwise, if they somehow were able to submit a request to deposit a negative amount of money, we return false, that there's something has gone awry. Otherwise, go ahead and do your thing and return true, so the deposit succeeded. Okay, and then withdraw is going to be defined similarly, but in reverse. So we make sure that you're not withdrawing a negative amount, and really this is more critical than the deposit one. But if you withdraw a negative amount, then you're crediting yourself without having to deposit anything. So don't allow that. Make sure that the actions are as expected, that you're always dealing with non-negative amounts, or in the case of these, you would want them to be strictly positive. A deposit of $0 is the same as no operation, and a withdrawal of $0 is also no operation. So we could be strict in our test here and make sure that that these values are strictly positive, but for now we'll just allow it to pass. Okay, so we have deposits and withdrawals, and we should be able to run. Okay, so it still compiles and executes. That's wonderful. So now let's go back to bank and transfer funds, which was not implemented, is now set up there. But we could also transfer funds directly from an account. So we have the reference to the bank, so we can use that. So we know the source account, so we just need the destination account, where are the funds being transferred to and how much. we'll just leverage, we'll reuse the transfer funds from there. The source account ID will be the account ID of the current account. The destination, we're just going to forward from the input parameters. And then the transfer amount will also be forwarded. And then a transfer is a composition. So we're going to want to keep a record of whether or not we were able to withdraw the money before we deposit it into the second account. Otherwise, it's a fairly major loophole. So the withdrawal, you could transfer money from an account if we don't put this test in, and the withdrawal from the source account would fail due to insufficient funds, so no money would be withdrawn. But then the bank would deposit or credit the amount to the other account, which is a major failure of design if you allow that to happen. So you want to keep a record and do this in a transactional manner, so that the funds are only deposited if they were successfully withdrawn from the source account, and the funds are only withdrawn if they were successfully deposited into the destination account. And so for now, we can really only guarantee that the source account had enough money and that the withdrawal succeeded. And then the destination account, it's usually easier to get the money to the person after the fact. But in such an edge case, like what would happen is if these bank records are processed at the end of the day and they're queued up, and the account was active and live, and then the actual transfer was supposed to happen later on, but on that very day the destination account was closed and the person left town. Such an edge case would fall through. But even that, the bank would have a means to resolve it. I forget which entity it is in Texas, but there's someone that will hold on to money that is in your name, but no one knew where to pay it to, and so that's managed by the state. So it's not as detrimental to the bank to not be able to deposit the money, but you got to make sure that before you even attempt to, that the money was there in the source account. So that's why we have this variable to track the success. So we need to make sure that the accounts exist. So if the key for the source account isn't known to the bank, then it won't approve it, and the same with the destination account. If either one of these does not exist, then the transaction is going to fail without attempting any work. Okay, so again, we're managing the edge cases. So now we've assumed that we have two valid accounts, and now we've proven it. If you get past this line, then both accounts are valid with this bank. So you can control the inputs. You can filter them down to just what you want using exceptions or these return codes. Okay. So then now we track whether or not we were able to withdraw. And the withdrawal amount is the transfer amount. And so if that succeeded, then we'll deposit it. and then we return success. Okay, that's fantastic. So now, as we develop this, we can create a scenario and we can manage it here, or I think since this whole exercise was about not just creating deposit and withdrawal ability, but the unit tests themselves. Let's create it in the unit tests. So the test library, so service-lib and then service-lib tests, these are parallel with one another. They mirror each other. So if we're testing something that lives in data models, then the convention that I follow, and it may vary from business to business, but the one that I follow is to create that same directory structure within this project, and then to create this parallel class so that we have account tests.cs and bank tests.cs. And so you can debate whether or not this is overkill, whether or not we need to, or if we could just survive with the bank tests. And I could be talked into just having the bank test. Right? So this is the idealized case where we have one class per class over here, and then even one unit test per function, or at least one unit test per function. But really, we're just trying to prove that our stuff works. So let's just focus on that. So we'll create it in just the bank, and that'll test both the account and bank data models to make sure that everything's up to par. So we'll want to copy the basic structure from over here. We have to change the namespace because we have it in some subdirectory, so we're going to want it to be data models. We have to indicate what we're testing, and we're testing service-lib. And it should be aware of service-lib, right? Yeah. We don't want to call it unit test 1. We want to call it the same as our file name by convention. So we want it to be bank tests. And then the method that we're testing, you can leave it as test method 1, that's fine. But I usually name it after whatever it is I'm testing. So we'll follow this convention. So class name, account, method name, deposit, and then some serial number for the test, right? So test 1. Right? So account deposit 1, or test 1. Account withdrawal. And then bank transfer. Okay. So there's a class called assert that should be available to us. But I guess we haven't run it yet, so it's not. Okay. So let's do the most basic thing. So I want to make sure that it's true. It's true, whatever test condition. And then if we have an error, we'll say some error occurred and then we'll pass it the name of our test class, and then the name of our test method. And then usually I like to include expected, some value like true, but received, but the actual value is false. Okay, so we should be able to get them to fail. Okay, great. So it skipped this one, as far as I can tell. And then each of these others failed. Right. So some error occurred during this test. So our message, the message that we constructed here, is printed whenever it fails. But if it passes, then you get a different message. It says that I guess they were all skipped. I don't know why they would have been skipped. It might be because this is a constant value and it didn't need to execute. So the compiler is pretty smart about that. So let's get rid of the classes that we're not actually using. Right, so unit test 1 and class 1. And this time whenever we run it, whenever we .NET test our test project, we'll only skip 3. But let's set up an actual scenario. So we want a bank. So let's create a new bank. Oh, and we need more than just service lib. We need service lib data models. Alright, not getting a lot of help there. Okay, so it's just the empty constructor, so we just need a bank reference. So now we can create an account. And we can pass it the bank. And then we need some initial balance. So let's store that in a variable. And we'll say that it's 2021 and 0 cents. And I believe that's correct. That's all we need. We need an account ID. Okay, so we'll need some account ID as well. That looks like a fine ID. I want to indicate that it's a long, so we append it with this L. And then we have to register the account with the bank. Okay. So now the bank has a record of the account, and we want to test the deposit. So we want a deposit amount. $151.00. and then we want to add that to the account. And so now we have an expected balance. And then we have the actual balance. And then we compare them. So are they equal? So the expected balance, actual balance, and then how much error we want to leave for round off whenever you're multiplying floating point numbers. And so if it's off by more than a cent, then it's not a floating point error. So you give it a cent, 1 penny's worth of tolerance. And then you say, if that fails, then this test produced an invalid balance. And in that case, we were expecting the expected balance, but we received the actual balance. Okay, so now if we run it, somehow it still skipped that. Oh, you know what? Earlier when it popped up, it asked me if I wanted to install some missing packages to run this. So if you install those, then you have the ability to run the test directly from VS Code. So on yours, when you do it, don't skip over that. Allow it to install those packages, and that'll help you out. But I'm already a couple minutes over, so you can continue this in this fashion. You can continue to write these tests, and you can make sure. And so whenever you're testing, you always want to test with valid input. You want to test with invalid input to make sure that it errors as expected. The valid input, make sure that it executes as expected. So this was the positive test. The negative test would be the invalid one. And then you want to handle edge cases as well. So what happens if you encounter overflow and so forth? For money, I don't think anyone is going to have more than is going to have enough money in a single account to overflow an 8-byte double. So it's probably not a great example of when you need to test an edge case. But you want to keep it in the back of your mind that if there is some valid input, like some positive number that could cause problems, that it's documented, or that you're at least aware of what the limitations of that function are. Okay, so we will, I feel like this is a decent intro into .NET, so we'll pick up with the Java project next time. So for that one, you're going to want to install Netbeans. So just type in Netbeans download, and just like the SDK for C#, you're going to want to install the JDK for this, which should come with Netbeans, because it's an IDE. It's intended to help you develop, so it should allow you to install the JDK. So install that if you want to follow along next time, and we'll write some code in Java. All right, have a good evening.